Microdian.
Hi everyone. Welcome to this webinar. Today, we will be discussing the Hipot tester and the 10 most commonly asked questions about electric safety testing. We will provide simple and clear explanations for each of these questions. We hope that you will find this webinar informative and useful. This is the outline today. Except the 10 FAQ, we will talk about the IEC standards introduction and our GPT 10,000 series of compliance with IEC standards. And we will share the useful functions of tester for test planning and the equipment deployment. The high potential test, also known as the Hipot test, is an important electrical test that assesses the ability of an electrical component to withstand high voltage. It involves a withstanding voltage test, insulation test, and grounding resistance test. Although these tests are popular nowadays, some engineers and operators may not fully understand them. To help with this, we have collected the 10 most frequently asked questions and hope that this section will be beneficial. First question: what voltage should be set for the withstanding voltage test? This is important because the purpose of the test is to apply a much higher voltage than the rated working voltage to the DUT as a trial. Therefore, it is crucial to choose a reasonable and adequate voltage. The answer to this question is twice the working voltage plus 1000 volts. For example, if the working voltage is 220 volts, the voltage should be set as 1440 volts for testing. This is the common withstanding voltage test formula. The additional 1000 volts is the anticipated maximum potential transient overvoltage based on the Category 3. Question 2. What is the most commonly used test voltage for withstand testing? There are 3 types of voltage: AC voltage, DC voltage, and impulse voltage, but which one is most commonly used for testing? The answer is AC voltage. AC is the most commonly used type of electrical power because it closely mimics the actual electricity environment. However, AC and DC voltage behave differently in capacitive circuits, so we need to provide further explanation in response to this question in next page. This figure is an equivalent circuit of the device under test, DUT. On the left, we can see the test voltage provided by the Hipot tester. The current flows through the DUT and is divided into resistive current, IR, and capacitive current, IC. There is a current meter marked A at the bottom to measure the dielectric current. This is the basic concept diagram for the withstand test, applying a high voltage, measuring and monitoring the change in dielectric current. Now let's see the difference between AC voltage and DC voltage. Left figure shows the AC voltage mode. If we apply AC voltage, since the polarity of the test voltage is switching constantly by 60 Hz or 50 Hz, so the capacitive current IC remains a steady state level and never goes to zero during the test. Because the capacitor never becomes fully saturated, the current is allowed to flow back and forth constantly without blocking. It means the leakage current is equal to the sum of resistive current IR and capacitive current IC. Now let's see the right figure. It shows the DC voltage mode. If we apply DC voltage, since the polarity is fixed, the capacitor will get fully charged, then block the current flow during the test. It means the leakage current is equal to the resistive current IR only. It also means the DC voltage is more accurate to the AC voltage, because we only want to monitor the change of resistive current IR. This is an important advantage of DC voltage. Although the DC is more accurate, we cannot ignore the fully charged capacitor. It needs the discharge action to release the accumulated electric charge to ensure the safety. We have created a chart to compare AC and DC test modes. AC mode is preferred for acceptance because it matches the actual electricity environment that is commonly accepted. DC mode is better for accuracy since it displays pure resistive current, which is ideal for monitoring. AC mode is better for range as it uses both polarities, whereas DC mode is safer because of the lower current during testing. Additionally, AC mode is better for discharge since it does not require it. The chart provides an overview of the main differences between AC and DC test modes. Question 3. How long should the test time be set? For time settings, there are typically 2 kinds. The first is called type test, which confirms the main and basic design criteria of a production lot and is usually set for 60 seconds. The second is called routine test, which is carried out on every product manufactured in the factory and is usually set between 1 to 3 seconds. Question 4. How to choose the output capacity of the tester? There are two typical standards: 500 VA and 100 VA. For 500 VA capacity, it is usually required in R&D unit or the laboratory of the third-party manufacturer. To conduct the destructive testing, the engineer usually needs the capacity more than 200 VA at least. For 100 VA capacity, it is commonly used in routine test of the production test. Question 5. What is the definition of insulator and insulation breakdown? This question seems simple, but it is worthy and necessary to dig out this topic. According to the definition of Wikipedia, an electrical insulator is a material in which electric current does not flow freely. This definition is simple and clear. But, what is insulation breakdown? This question is not often discussed, and most people may not able to respond to this question promptly. Here we find the definition. According to the IEC, it says, insulation breakdown is considered to have occurred when the current that flows as a result of the application of the test voltage rapidly increases in an uncontrolled manner, that is, the insulation does not restrict the flow of the current. The very important sentence is rapidly increases in an uncontrolled manner. It means, even if the current is rising, but it is stable and under control, it cannot be regarded as an insulation breakdown. The purpose of a dielectric test is not to evaluate the amount of leakage current, but rather to monitor the behavior of current rising. Only a sudden and dramatic increase in current can be judged as an insulation breakdown. Question 6. According to the definition of insulation breakdown, how do we avoid misjudgment? After question 5, we already understand the definition, but what is the best way to make the correct judgment? The best way is using the VI curve function. In the figure, we can see the current is rising slowly and proportional to the applied voltage level in beginning. Then we can see the current suddenly rising rapidly at a point and exceeds the high limits of the current setting. Since we can observe a sharp change in the VI curve, we can conclude that this is due to an insulation breakdown. Question 7. Does the appearance of arc and flashover mean that the insulation has broken down? The answer is no. According to the IEC standard, it mentioned, corona discharge or a single momentary flashover is not regarded as insulation breakdown. Arc detection function can be used as a further testing function, but it is not the beacon to help to judge if the DUT insulation is breakdown. Question 8. In the test sequence of IR and withstanding voltage, can the withstanding voltage be excluded after passing the insulation resistance test? The answer is cannot. The standard test sequence is IR, ACW, or DCW, and followed by IR again. IR test is usually applying the rated voltage to measure the resistance, while the withstanding test is testing at a much higher voltage. If there is a small defect in the resistance structure of the DUT, it may not be detectable during an IR test since the test is conducted under normal working voltage conditions only. Therefore, in order to verify the integrity of the DUT's insulation resistance, we can conduct a withstanding test between two IR tests and compare the difference in the IR results. Question 9. This is a special question. Will the high voltage withstanding voltage test damage the expensive chips in the circuit? There will be no damage as long as the withstanding voltage test is passed. Based on this question, there is a related topic we can talk about. In the microscope photo, it shows the two copper conductors are short circuit due to the dendrite debris. The debris is generated by ion migration effect, which occurs in high humidity environments with voltage applied. Question 10. What is the difference between grounding and continuity measurements? Shown as the figure, both tests are going through the DUT chassis and the protective earth conductor of the plug, so what's the difference between both tests? Grounding test, as known as ground bond (GB) test. It applies high current to verify if the ground wire is capable of handling excessive current. Continuity test verifies the connection of grounding path by applying low current from the chassis to the ground pin. It usually performed in Class 1 product. In short, the applied current is different. GB is checking the capability to carry high current. Continuity is checking the connection by low current. Now let's talk about the IEC 61010 Part 2-034 standard. We will not go through the detail. Here, we only introduce the key points. We will address this topic in 3 steps: what, why, and how. What is this standard? This standard describes the safety requirements for electrical equipment for measurement, control, and laboratory use. It specifically addresses measurement equipment for insulation resistance and test equipment for electric strength. Why is this standard important? Because it pertains to safety. The purpose of the standard is to minimize the risk of injury and reduce potential hazards. Given that the Hipot tester utilizes high voltage to test the DUT's safety, it is crucial that the Hipot tester ensures its reliability and safety before use. Now that the IEC standard has been officially released, only testers that meet the standard should be selected to eliminate any potential hidden risks. How the GPT 10000 series comply with IEC standard? Our engineering team improves multiple aspects of design and adding safety function to make the GPT 10000 series becomes the world's first safety analyzer, conforming to this IEC standard. Next, let's introduce how GPT 10000 series comply with the IEC standard. First is component design change. For the high voltage relay and transformer, we change the design to meet the requirement of double insulation. Second is mechanical design changes. This photo shows the connection part of high voltage output probe. We change to the new design to meet the double insulation requirement. Third is the change the circuit design. In left figure, we add 2 protect resistors to isolate a danger voltage from high voltage side matching with the requirement of double insulation. In right figure, we redesign the layout of PCB to increase the creepage distance to 50 mm to meet double insulation. Fourth, we add a 56K ohm discharge resistor. It is for the DC withstanding test. If the DUT has a large capacitor, it needs the discharge action to release for safety. Fifth, we add the output indicator to aware the operator. Sixth, we add 2 new mechanisms for safety. One is the grounding check. If grounding check fails, the output will be disabled. The other is the start button. The start button has to be pressed and hold for 1 second to trigger the output. This function can avoid the wrong trigger if pressed by mistake. This function can be turn on or turn off in the utility setting. Now let's go to next section. This section we are going to talk about the test planning and equipment deployment from R&D to production testing. First, the safety analyzer must have the VI curve scanning function to confirm insulation breakdown. This is a standard equipped function for GPT 10000 series. As we mentioned in earlier section, only the change of current curve is the main factor to judge if the result is a breakdown or not. For the research and development stage, this function becomes a must-have tool. For production applications, the GPT 10000 offers statistical analysis functions that enable a quick review of the quality results. It not only shows pass or fail, but also provides a histogram for quality analysis. If it requires simultaneous testing of numerous DUTs to save time for large-scale production, the GPT 9500 series with its built-in 8-channel scanner is the ideal choice. Additionally, the GPT 9500 is also compliant with IEC standards to ensure its safety for use in production applications. The previous GPT 9900 and GPT 9800 series models are also capable of multi-channel scanning by combining the GSB multiplex scanner box. We offer a full range of GPT series Hipot testers with capacities ranging from 100 VA to 500 VA. In addition, we provide GLC 9000 and 10000 leakage current testers to check the DUT's leakage current during operation. Our product line offers a complete range of safety solutions. Please check out the landing page by scanning the QR code for more detail. Now, let's summarize in 3 points. First, ensuring safety should be the foremost consideration when using a Hipot tester. Therefore, the Hipot tester must comply with IEC standards. Second, the tester must have the VI curve function to accurately detect insulation breakdown. Third, the provider must offer reliable support.